I mean, we all have thoughts, obviously. But have you ever stopped to wonder what a thought actually is? It's like the most basic part of being you, right? And yet, how a single clear idea like, I wonder what's for dinner, can pop out of the 3 pounds of wet, messy hardware in your skull. Well, that's still one of the biggest mysteries out there.
So let's get right into it. This is the central problem. Your brain is buzzing with billions of neurons, all firing off signals in what looks like, for all the world, total chaos. So how does that microscopic lightning storm manage to organize itself, just for a moment, to create a single, stable experience that we call a thought? How does order come from that noise?
You know, the standard answer we all learned is that it's all about electrochemical signals. Neurons fire, they talk to each other, they form networks, and voila, you think. And look, that's not wrong, but it's also not the whole story, not by a long shot. That's kind of like saying a symphony is just a bunch of people making sounds. It leaves out the most important parts.
So the material we're digging into today proposes this really new and frankly cool way of looking at it. It frames mentation, that's just the fancy word for the process of thinking, as a kind of recipe. It argues that for any real thought to actually happen, you need 3 key ingredients to all come together at the exact same time.
Okay, so ingredient number 1 is something you might have heard of before: phase coherence. The easiest way to think about this is rhythm. See, it's not enough for your brain cells to just be active. For a thought to take shape, huge groups of neurons all across the brain have to fire in sync with a coordinated rhythm. It's exactly like an orchestra. If every musician just plays their notes whenever they feel like it, you get a mess. But when they play in time, together, you get music. That's phase coherence. Ingredient number 2 is what's called network integration. So, a simple reflex, like when you touch something hot and pull your hand back without thinking, that can have some coherence, sure, but it's a very local thing. A real thought, on the other hand, is a brain-wide event. Integration just means that the information is being shared globally, connecting your vision centers with your memory centers, with your emotional centers, the whole shebang. It's the difference between a tiny little tremor and a planet-wide earthquake. So we've got rhythm and we've got reach, coherence and integration. That sounds pretty solid, doesn't it? Seems like that would cover it. But this new framework says, hold on, there's a third ingredient. And this one is a real game changer, because it's not just about electricity. And here it is, the wild card: tissue mechanical modulation. Get this, the theory says that our brain isn't just an electrical computer. It's a physical object, and its physical properties matter. The actual stretching, the tiny vibrations, the pulsing of the brain tissue itself, which is influenced by stuff like your blood flow, that physical environment actually changes how and when neurons are able to fire. So the mechanical state of your brain is an active ingredient in your thoughts. Wild, right? And this quote right here just nails the main point. A thought isn't just one of these things. It's what happens when all 3, the electrical rhythm, the global network connection, and the right physical tissue environment, all snap into place at the same time. When they all cross a certain threshold together, click, a stable thought emerges. So what happens when you start playing with this recipe? Well, depending on the mix of these ingredients, our thinking can take on totally different flavors. The framework calls them crystal-like and fluid-like states of mind. Now, to really get this, there's just one quick concept we need: a tracker depth. Just imagine a hilly landscape with a bunch of valleys. A really deep valley is a deep attractor. Once a marble rolls into it, it takes a lot of energy to get it out, right? A shallow little dip in the ground is a shallow attractor. The marble can get bumped out of it and roll into the next one pretty easily. In our brain, a thought pattern is kind of like that marble. And this idea connects directly to how we feel and think every day. A crystal-like state is when your brain is using those deep attractors. This is your brain on autopilot, it's your rigid habits, your strongly held beliefs, or when you're executing a skill you've totally mastered. It's super efficient, but it's not very flexible. Then you have the fluid state with those shallow attractors. This is your brain when you're brainstorming, or maybe even dreaming. Your thoughts can just leap from one idea to the next, making new connections. It's creative, flexible, and open. Okay, so how does the brain actually use these different states? Well, one of the most powerful parts of this framework is how it explains something we all take for granted, how we can tell the difference between what's really out there and what's just in our heads. Seriously, think about that for a second. The experience of actually seeing a tree and the experience of vividly imagining a tree, they use a lot of the same parts of your brain. So how on earth does your brain not get them mixed up all the time? How does it know what's real and what's imagination? Well, according to this model, the answer is that your brain is in a constant tug of war. It's always balancing two competing streams of information. The signals coming in from your senses, your eyes, your ears, and the signals being generated internally from your memories. Your conscious experience at any given moment is just the outcome of that push and pull.
And this is where it gets so elegant. The framework proposes something called a phase ratio, but you can just think of it as a dial. When that dial is turned way down, the signals from the outside world are dominant. That's your brain in perception mode. You are locked into reality. Now turn that dial all the way up. Suddenly, the internal signals from your memories are the loudest thing in the room. That's imagination or dreaming. And what about in the middle? Well, that sweet spot is where you get creative thought, a perfect blend of what's real and what you can imagine.
Okay, I know what some of you might be thinking. Crystal thinking? A mental dial? Is this all just a bunch of clever metaphors? And that's a fair question. But the authors of this framework are really clear that the whole point of this is to move beyond metaphor and build a real testable science of the mind. You see, for this to be actual science, it has to follow the rules. All these things, the variables like phase coherence or network integration, they have to be things we can actually measure with our existing tools like EEG. The thresholds, that tipping point where a thought pops into existence, have to be definable. And this is the most important one, the theory has to make predictions that could actually be proven wrong.
And here's a perfect example of what that looks like. It's a falsifiable prediction. The theory says the physical pulsing of brain tissue matters, right? Okay then, if you could find a way to safely, experimentally change the tiny pulsations of blood vessels in someone's brain, you should see a direct, measurable change in their brain's electrical rhythms while they're doing a thinking task. If you run that experiment and you don't see that effect, then the theory's got a problem. That's what makes it science.
So at the end of the day, that's the big ambition here. It's to give us a real scaffold, a set of tools and testable ideas that can help us finally build a true, empirical, scientific model of how the mind actually emerges from the brain. It's about moving from just describing the beautiful mystery to actually having a blueprint.
And that leaves us with one last huge question to chew on. If this framework, or something like it, turns out to be right, it means that our thoughts, our creativity, our most deeply held beliefs, they aren't just these abstract, ghostly electrical patterns. They are fundamentally shaped by the physical, mechanical squishiness of our own brain tissue. So what does it mean for who we are if our very consciousness is tied not just to the spark of a neuron, but to the actual stretch and pulse of the brain itself?